Good morning, children. You know what is lark? L-A-R-K. It is a small bird called songbird, which is a ground-dwelling bird with a brown streaky plumage. Once, the lark in the forest saw a man walking with a box in his hand. The lark stopped him and asked what he was carrying. The farmer replied that he was carrying a box full of worms to the market to trade them for feathers. The lark thought, I have so many feathers on my body, so let me pluck one feather and give it in exchange of worms. Farmer said yes. The lark plucked one feather and in exchange of worms. The man went away. The lark was very happy because that day's food, there was no need for the bird to hunt for. Lark was very happy. This went on and on, the next day and so on, until a day came when there were no feathers on its body to give it in exchange of worms. And that bird was looking ugly without feathers on its body. Other birds were scared of going near this bird. It could not fly to hunt for the worms. And finally, bird was starving and life came to an end. It died. There is a moral in this story, dear children. The lark thought of an easy way of getting its food, but over a period of time, that easy way became a tougher way. This applies to our lives also. If we look for shortcut method for achieving success, it is not going to last long, or we may not be able to achieve what we desire to achieve. So hard work and discipline are the prerequisites for a student to achieve great success in his scholastic career. Now, in arithmetic progression, we derived the formula to find the nth term. We wrote the formula an is equal to a plus n minus 1 into d, where an is the nth term, a is the first term, n is the number of terms, and d is the common difference. Now let's do some more problems using this formula in today's class. Now there is a first problem. Find the 10th term of the AP, 2, 7, 12 and so on. You are asked to find the 10th term. Here I write A equals to 2. Common difference is second term minus first term. 7 minus 2, that is 5. And you are asked to find the 10th term, that is A10. You have to find. Write the formula an equals to a plus n minus 1 into 2. And substitute here a10. In place of n, write 10. In place of a, write 2. Plus n is 10 minus 1 into common difference is 5. So 2 plus 10 minus 1, 9 into 5, 45. So a10 is equal to 47. So this is the 10th term. Then coming to the second problem. Which term of the AP 21, 18, 15 and so on is minus 81? Which term of this AP is minus 81? That means minus 81 means it is the last term. An is given minus 81. A is given 21. Okay, and what's the common difference? It is 18 minus 21 or 15 minus 18. that is equal to minus 3. Equal to minus 3. Verification, if I add minus 3 to 21, I must get 18. If I add minus 3 to 18, 18 plus of minus 3, it is 15, and so on. Then use the formula an equals to a plus n minus 1 into t. An is minus 81 equals to 21 plus n is not known into common difference, it is minus 3. So minus 81 equals to 21, minus 3 into n minus 3n, minus 3 into minus 1 plus 3. So minus 81, 21 plus 3, it is 24 minus 3n. 21 plus 3, 24 minus 3n. Then minus 81, bring 24 this side, minus 24 is equal to minus 3n. Or minus 3n is equal to, add these two, minus 105. Minus minus cancel, n is equal to 105 divided by 3. So 3 3s are 9, 3 5s are. So number of terms is 35. So which term is minus 81? A35 is equal to minus 81. A35 is minus 81. We shall go to the third example. Determine the arithmetic progression whose third term is 5. A3 is 5. And seventh term is 9. A7 is 9. So what we can do, A3 is nothing but A plus 2D. This is direct way of writing. You can as well use the same formula, A plus n minus 1 into D. A3 is equal to A plus 3 minus 1 into D. 3 minus 1, it is 2D. Okay, instead of writing the formula and substituting, we can write the first term as A, second term A plus D, third term A plus 2D, likewise. So this is the third term A3, A plus 2D. What is the seventh term? A7, it is A plus 6D, seventh term. So A plus 7 minus 1 into D, A plus 6D. Now A plus 2D is equal to 5, A plus 6D is equal to 9, subtract. So when you subtract, the sign will change. Plus plus, this becomes minus, these two get cancelled. So this is minus, this minus. Minus 6D plus D minus 4D equals to minus 9 plus 5, it is minus 4. And D equals to 4 by 4, minus minus get cancelled. It is D is equal to 1. Common difference, we got it as 1. I take this A3 equals to A plus 2D. And A3 is 5 is equal to A plus 2 into 1. So 5 equals to A plus 2. If I shift this 2 to the left hand side, 5 minus 2 is equal to A. Therefore, A is equal to 3. We got the value of A as 3. Common difference is 1. So you should be able to write the arithmetic progression. I write that AP here. So AP is, so the first term A is 3. Common difference is 1. Add 1 here, 4. Then 5 and so on. So this is the arithmetic progression. Now coming to the fourth example. Check whether 301 is a term of the AP, 5, 11, 17 and so on. So 5, 11, 17. You have to find out whether 301 is a term. So let us assume that AN equals to 301. Okay, it's only assumption. We still do not know whether 301 is a term, belongs to this AP or not. So A is equal to 5. Common difference D is equal to 11 minus 5. So that is 6. 11 minus 5. A2 minus A1, 6. So AN is 301. N you are expected to find. N. I use the formula AN is equal to A plus N minus 1 into D. Now an is 30 is equal to 5 plus n minus 1 into 6. So 30 is equal to 5 plus 6 into n, 6n minus 6. 30 equals to 5 minus 6 minus 1 plus 6n. Bring minus 1 to the left hand side. 30 plus 1 is 6n. 6n is equal to 31. n is 31 by 6. n is 31 by 6. Do you get the value of n, a whole number? I remember having told you very clearly, repeatedly, that n is the number of things. Therefore, it cannot be negative, it cannot be a fraction. It has to be a whole number, or you can say natural number. It has to be a natural number. So, since n is not a natural number, I should say that n is not a natural number. A natural number. So therefore 301 is not a term. Is not a term of the AP. 301 is not a term of the given arithmetic progression. Now one more last example we shall take. How many 2-digit numbers are divisible by 3? 2-digit numbers, recall, 11, 10 is a 2-digit number, 11, 12, 13, but divisible by 3. 10 is not divisible by 3, 11 is also not divisible by 3. Therefore, the first 2-digit number divisible by 3 is 12. 12 plus 3, 15. 15 plus 3, 18. So, these are all, these are all, you can say, the numbers divisible by 3. They are all numbers divisible by 3. So as such, I write 12, 15, 18 and so on. And a is equal to 12. So which is the last number? 99 is the last number. All 2-digit numbers. The question is, how many 2-digit numbers are there which are divisible by 3? Starting from, you can say 10 up to 99. 100 is a 3-digit number. From 10 we need to consider, since 10 and 11 are not divisible by 3, right? So the first number divisible by 3 is 12, then it is 15, 18 and so on. A is 12, an, the last term is 99, common difference D is A2 minus A1, 15 minus 12, that is 3. So use the formula an is equal to A plus n minus 1 into D. An is equal to A plus n minus 1 into D. So, substitute values. An, that is 99, is equal to 12 plus n minus 1 into common difference is 3. So, 99 is equal to 12 plus 3n, 3 into minus 1 minus 3. 99 is equal to 12 minus 3, 9. Plus 3n. So 99 minus 9 is equal to 3n. So 3n is equal to how much? 90. 3n is equal to 90. n is equal to 90 by 3. So that is 30. So you should understand that there are 30 such 2-digit numbers which are all divisible by 3. Okay? The numbers, 2-digit numbers which are divisible by 3, between 10 and 100, it is 30. Understood? So such very simple problems are there in the textbook. Even if you don't have the textbook, in the PDF format it is available in the website if you go there, and you can download or at least view that one. Exercise 1.2, page numbers 13 and 14. Page numbers 13 and 14. From first main to 6th main you need to do for the next class. From first main to 6th main assignment. In your assignment book or in the classwork you need to do these sums. Thank you. Have a good day.